Hello there, and welcome, Cosmic Lullaby Channel. Find a comfortable place to rest your head as we drift into one of the oldest and most mesmerizing forces on Earth: fire. It is a presence that has warmed our world since the beginning, a constant companion in the long story of this planet. It is both a destroyer and a creator, a flicker of gentle warmth and a storm of silent chemistry. Long before the first cities rose from the earth, before language gave names to the stars, before the very first words for light or heat were ever whispered, there was fire. It spoke in the deep darkness, a quiet and living voice, shaping the course of human history in ways we can only begin to imagine. From the moment our distant ancestors first learned to tend to a glowing ember, everything changed. It was more than warmth, it was safety. A circle of light in a world of endless shadow. A place to gather, a place to finally feel at peace. It has lived in our myths as a gift from the gods. It has powered our machines with its contained strength. It glows in our stars as a cosmic promise, and it burns in our hearts as a symbol of passion and spirit. Fire is not truly a thing, but a transformation. It is a living border, a gentle threshold between what was and what will be. When you gaze into a flame, you are watching a process unfolding at a breathtaking, silent speed. It is a chain reaction made beautifully visible to the human eye. Think of it as a quiet, continuous dance. Molecules of fuel from a log of wood or the wax of a candle meet with molecules of oxygen from the air around us. In that meeting, they greet each other, they break apart, and they recombine into something entirely new. Each tiny reaction, so small it is impossible to see, releases just enough energy to ignite the next one beside it. This constant, seamless renewal is what creates the shimmering, steady light that we see. What looks like a single, stable flame is actually a symphony of millions upon millions of chemical transformations, happening every single second. It is a river of change, flowing upwards into light. As the bonds between atoms break, their electrons shift into new and more stable arrangements, releasing the energy they once held as both heat and photons, tiny packets of light that travel to our eyes as a soft radiance. The flame dances because the surrounding air is always moving, always breathing. This constant flow of air alters the delicate balance of fuel, oxygen, and heat. If there is too little of any one element, the chain reaction collapses and the flame fades into darkness. If there is too much, it flares with a sudden, violent life before vanishing just as quickly. It is a lesson in perfect equilibrium. The gentle, hypnotic flicker of a single candle and the roaring, unstoppable wall of a wildfire are governed by the exact same chemistry, different only in their scale and speed. Fire is the visible signature of matter transforming itself, a living masterpiece showing how energy moves through the world in a state of pure, uncomplicated motion. A flame is a boundary, a delicate frontier where chemistry turns into light. This is where the magic happens. Between the unburned air around it and the hot, invisible gases of combustion lies a razor-thin frontier where molecules are destroyed and reborn in the same instant. Within this luminous golden skin, atoms rearrange themselves at astonishing speed, trading their bonds and releasing photons into the air. The light itself comes from particles so small and fleeting that they exist only for moments, glowing as they cool and finally vanish. A brief and beautiful life, lived in a heartbeat. The flame's color changes with its temperature and with the different elements burning inside it, painting the boundary in soft blues, warm yellows, or brilliant white heat. The shape of the flame, that familiar, gentle teardrop, reveals the perfect balance between energy and motion. It is a dance between convection lifting the hot air upward and the pull of new oxygen from below. In that slender, shimmering region, matter gives up the energy it has stored for years, perhaps decades, turning the invisible into the visible. What we see as a soft, comforting light is the final beautiful expression of chemistry, reaching its completion. The bright skin of transformation glowing in the air before it dissolves back into the quiet darkness. When something burns, it is not disappearing, but merely changing its form. Nothing is ever truly lost. Combustion is matter rearranging itself through heat and motion. When something burns, it is not disappearing, not vanishing from the world, but simply changing form, gracefully and completely. The atoms of the fuel, locked away for ages within wood or wax, combine with oxygen from the air to create entirely new molecules. These are mostly carbon dioxide and water vapor, the very same things we breathe out with every sigh. A very calm, soft, and soothing voice, slow-paced, with gentle intonation. As this happens, the energy that once held the old molecules together is released. That energy rushes outward as heat, sound, and light, driving the next instant of the reaction in a self-sustaining cycle. Each molecule that reacts gently transfers its energy to its neighbors, a microscopic relay race that continues until the available fuel is gone. What remains is ash, the quiet, soft fraction of the material that cannot take part in the great exchange. It is the earthbound part of the story, the minerals that could not ascend into light and air. In the warm glow of combustion, chemistry becomes visible, revealing the hidden restlessness of matter. The same universal principles that drive a simple candle flame also govern the engines that move our world and the great fires that shape our landscapes. Every single burst of heat is a small act of creation, an endless, silent rearrangement of the building blocks of reality itself. The color of a flame reveals the hidden story of the elements being consumed. It is a form of language, a secret script written in light. When a substance burns, its atoms release their stored energy in precise, perfect amounts, and those amounts decide what color we see. Think of the stars. Their light travels for millions of years, carrying these same secrets, the same fingerprints. A candle flame and a distant sun, speaking the same language. Sodium, for instance, burns with a bright, familiar yellow. Copper creates ethereal greens or blues, like a fragment of the ocean caught in the fire. And strontium glows with a deep, resonant crimson. These beautiful colors come from the electrons within the atoms, jumping between energy levels and releasing photons of exact, specific wavelengths as they fall back to a state of rest. The spectrum of light from a flame acts like a unique fingerprint for the elements inside it, allowing scientists to identify materials by their colors alone. In the spectacle of fireworks, this principle becomes art, as metal salts are carefully chosen to paint the night sky with silent, blossoming color. But even in a simple candle flame, a whole rainbow exists. The soft blue near the base marks a region of complete combustion, a perfect, efficient reaction, while the warm yellow glow higher up comes from tiny carbon particles radiating heat, shining brightly for a moment before they too vanish. Each hue tells a story of atoms giving up their energy, a final brilliant signature before they change forever. The hottest part of a candle flame hides in plain sight, just above the wick. The familiar teardrop shape of a candle flame seems so simple and calm, but its heat is unevenly and beautifully distributed. The region just above the wick, where vaporized wax mixes perfectly with oxygen, burns the hottest. Here, in this nearly invisible space, temperatures can reach over 1,000 degrees Celsius. The lower blue edge of the flame marks where the reaction is most complete, while the yellow and orange glow higher up comes from cooler carbon particles radiating their gentle light before they fade away. The wick itself, the thread at the very heart of the flame, remains mostly unburned. This is because the vaporized wax draws the flame upward, away from the delicate fibers. A blue flame marks a perfect, harmonious balance of fuel and oxygen, a state where nearly all molecules burn completely and cleanly. Because there are no leftover carbon particles to glow yellow, the flame shines with a pure thermal light, a light that comes directly from excited molecules at very high temperatures. A blue flame is a quiet worker, doing its job perfectly, leaving almost nothing behind. The color blue itself corresponds to higher energy photons, meaning the reaction releases more of its power with every collision. That is why gas stoves and torches burn blue, producing a steady, powerful heat that is ideal for cooking or welding. Orange flames, in contrast, come from incomplete combustion, where glowing soot particles radiate their light at cooler temperatures. Their beauty lies in the visible carbon that the more efficient blue flames have already consumed. One is pure efficiency, the other a gentle, glowing story of imperfection. And yet, not all fires blaze with this intense heat. In very special conditions, flames can exist at surprisingly low temperatures. These are known as cold flames. They glow with a faint, ghostly blue and can stay below 200 degrees Celsius, cool enough to touch for just an instant without causing pain. The reaction occurs slowly, patiently, releasing its energy over time instead of in violent, brilliant bursts. These ghostly flames remind us that fire is not defined by heat alone, but by transformation itself, the quiet, steady rearranging of matter into light. Although oxygen is the most common supporter of combustion on our world, it is not unique. Fire can exist in almost any gas if the fuel and the oxidizer are perfectly balanced. Many gases, from fluorine to chlorine, can sustain a fire if the right fuel is present. What truly matters is that delicate balance, the perfect proportion of reactants and the energy needed to break their bonds. A little too little oxidizer, and the flame dies for lack of breath. A little too much, and it consumes itself in a single brilliant flash. In laboratories, scientists have created flames in atmospheres of hydrogen fluoride or pure chlorine, each with its own distinct colors and behaviors. Some of these exotic fires glow green or violet. Others are nearly invisible to the human eye. It is a quiet reminder that the fire we know is not the only kind of fire. It is simply our kind. These exotic flames reveal that combustion is a universal language of chemistry, dependent only on the ability of atoms to exchange electrons. Wherever energy can be released through the breaking and reforming of bonds, fire can appear, even in environments far, far removed from the gentle air that feeds our familiar earthly flames. What fire consumes, it also transforms into entirely new substances. Burning is a process of creation just as much as it is a process of destruction. When wood burns, its cellulose breaks down into gases, ash, and charcoal. The hydrocarbons within the fuel combine with oxygen to form carbon dioxide and water vapor, releasing energy in the process. The flame is both the cause and the beautiful evidence of this transformation. Every wisp of smoke that drifts upward carries molecules that once formed part of something solid and strong. A tree that stood for a century, now rising to join the sky. Even the minerals left behind in the soft gray ash are the rearranged remnants of the original material, altered by heat and exposure. In this way, fire acts as nature's great agent of change, converting complex organic matter into simpler, more stable forms. Nothing truly vanishes, it simply shifts into new arrangements of atoms. A very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. What was once solid structure becomes flowing energy, and what was once stored energy becomes warmth and light. Through fire, matter writes new chapters of its own story in the silent language of chemistry. The gentle crackle of burning wood comes from moisture flashing into steam. Inside every piece of wood, even one that feels perfectly dry to the touch, tiny pockets of water hide between the fibers. As the deep heat of the flame reaches them, that hidden water expands instantly into steam, building pressure until it bursts through the wood's surface. Each pop or crack is the sound of those miniature, harmless explosions. It is the sound of release, the sound of a story being told, a story of rain and seasons past. At the same time, the sap and other trapped gases add their own voices, snapping and hissing as they escape into the air. The result is a living, breathing soundscape, a reminder that burning is not a silent transformation, but a physical and audible struggle within the material itself. As the wood continues to heat, it releases volatile gases that feed the flame, turning solid matter into fuel for the fire. The rhythm of crackling logs reflects the perfect balance between moisture, heat, and release. It is the final dialogue of a living substance returning its stored energy to the world, as warmth, light, and sound. And then there are the sparks, tiny particles of matter glowing from intense oxidation. When a spark flies from a fire or a grinding wheel, it is a tiny speck of material heated so quickly that it glows before vaporizing. It is a brief moment of glory, a final, brilliant flash. A very calm, soft, and soothing, designed for relaxation and meditation. As the particle leaves the main flame, oxygen in the air attacks its surface, creating a miniature fireball of oxidation. The heat generated by this tiny reaction is immense compared to the particle's size, often exceeding temperatures that can melt steel. The bright trail it leaves behind is the light of atoms losing electrons and forming oxides. A little comet on a journey of only a few feet. Even the sparks from a simple campfire follow the exact same principle. Tiny fragments of fuel lifted into the air by rising heat, each one completing its own brief and beautiful combustion. Every spark is a microcosm of the larger flame, a self-contained burst of transformation that lasts only for an instant. The shimmer you see just above a flame is the air itself bending light as it heats. Above every flame, the air ripples like a gentle mirage. The heat rising from the combustion changes the density of the surrounding gas. And as light from across the room passes through it, this shift in density bends the rays in soft, unpredictable ways. Our eyes perceive this bending as a shimmer or a distortion, like waves of pure transparency. This very same principle causes the road to appear wet on a hot summer day, or a distant desert horizon to waver in illusion. What looks like a soft, gentle halo of movement is really the signature of convection, the visual language of the air translating invisible gradients of temperature into visible motion and light. It is the fire's breath made visible for us to see. Flames flicker because the rising air keeps reshaping the delicate reaction. A flame is not a fixed shape, but a moving, breathing balance of chemistry and air. As the hot gases rise, cooler air rushes in to take their place, feeding the fire with fresh oxygen while simultaneously disturbing its form. This constant ebb and flow creates small, invisible pockets where the fuel-to-air ratio shifts, causing the flame to dance and pulse. It's a quiet, hypnotic rhythm, a conversation between the heat and the world around it. Even the tiniest, most imperceptible movement in the surrounding air, like your own soft breath, alters how the heat spreads and how fast the molecules can collide. In perfectly still environments, like a sealed chamber or in the microgravity of space, flames can hold a steady, unwavering shape, revealing their true, serene nature. But here, in the open air of our world, convection currents constantly sculpt the flame, making it breathe and move like a living thing. The flicker we see, the gentle dance that has captivated humanity for millennia, is the visible expression of equilibrium being tested and re-established again and again and again. It is the heartbeat of fire, responding endlessly and gracefully to the air that gives it life. This is especially true of candlelight, a light formed from glowing carbon particles just before they vanish forever. Inside a candle flame, the wax vapor rises and reacts with oxygen, breaking apart into carbon and hydrogen atoms. The hydrogen burns cleanly and invisibly, producing heat and water vapor. But the carbon lingers for just a moment longer, forming tiny, microscopic particles of soot. It is this soot, this imperfection, that gives candlelight its magic. These microscopic bits of carbon are heated until they glow, releasing the warm, gentle yellow light we associate with peace, with history, and with home. As they rise through the flame, they are eventually consumed completely, leaving behind only invisible gas and the faintest traces of ash. This process creates a beautiful gradient of temperature and chemistry, from the pure blue at the base where combustion is perfect, to the golden, honeyed hues near the top, where the particles shine and then disappear. The light of a candle is not from the fire alone, but from matter on the very edge of vanishing. Each tiny carbon particle glowing for a single heartbeat before dissolving into the air. The flame's beauty lies in that final, fleeting instant of transformation. It is a soft light, a forgiving light, a light that has illuminated human faces and hopes and stories for thousands of years. The very shape of a flame is drawn by the speed of the surrounding air. A flame's form depends entirely on how quickly the air moves around it. In calm, still conditions, the hot gases rise straight upward, creating the familiar, elegant teardrop shape. When the air moves faster, the flame stretches, bends, or flickers sideways, responding to the invisible current. That smooth, gentle contour is the visible outline of convection, where warm air rises and cooler air rushes in to replace it. The air itself becomes a sculptor, shaping the light. If the airflow becomes turbulent, the flame breaks into chaotic, beautiful forms, twisting into waves or torn, fluttering edges. Engineers and scientists study these shapes to understand combustion efficiency, because every curve and every flicker reveals exactly how heat and oxygen are interacting. In zero gravity, where air no longer rises, the flame becomes a perfect silent sphere, shaped only by the slow process of diffusion. The geometry of fire is therefore not random, but sculpted by motion. It is a constant, graceful interplay between the chemistry of the reaction and the invisible currents of the air that feeds its breath. And fire can produce sound as its pressure waves vibrate the air. Every flame, no matter how small, generates subtle fluctuations in air pressure. When combustion happens rapidly, the expanding gases create waves that move outward as sound. The gentle crackle of a campfire, the deep roar of a furnace, and the low, quiet hum of a gas flame are all different expressions of the very same phenomenon. It is the voice of fire, a voice that has spoken to us since the dawn of time, a sound that signifies warmth and safety. Each unique sound depends on how fast the gases expand and how irregularly they escape. In large fires, these vibrations can become so strong that they create deep, resonant tones. Scientists study these sounds to monitor the stability in engines and rockets, where flame-driven pressure waves can become dangerous. But even a quiet candle hums faintly, though it is far too soft for our human ears to hear. Fire has a voice because it moves the air that surrounds it, translating chemical energy into vibration, turning heat and light into a soft music of pressure and motion, a primal lullaby for a world drifting off to sleep. At high enough temperatures, the atoms in a flame become partially ionized, creating a state of matter that can conduct electricity like a weak, invisible wire. This creates plasma, the fourth state of matter, which behaves both like a fluid and an electrical conductor. Though the effect is weak in an ordinary fire, it can be measured with sensitive instruments. If you were to place a flame between two electrically charged plates, a very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. You could actually see it bend and stretch. Electric fields can manipulate a flame, proving that charged particles are present within its gentle glow. In powerful plasma torches and in the raw, beautiful chaos of lightning, this conductivity grows powerful enough to cut through solid metal or light up the entire sky. But in a simple candle flame, the very same principle exists in miniature, a quiet whisper of the same process that powers the sun itself. Fire, in this sense, bridges the gap between chemistry and physics, existing halfway between solid matter and pure energy. Its plasma core carries a soft current through the air, linking each burning molecule in a delicate web of light and motion. It is a quiet reminder that even the smallest flame holds a connection to the great cosmic forces that shape our universe. Fire also behaves differently in every gravity environment. Gravity is the invisible sculptor that shapes how hot gases move. On Earth, it pulls cooler, denser air downward, while the lighter, hotter gases rise, creating the familiar flickering teardrop shape of a flame. But if you were to light a candle on the Moon or on Mars, where gravity is weaker, convection would slow down and the flames would grow wider and dimmer. Without the strong pull of gravity to drive the circulation of air, combustion would depend more on the slow, patient process of diffusion, the gentle, random mixing of molecules. And in orbit, where weightlessness dominates, flames become perfect, silent spheres, glowing evenly in all directions with no flicker at all. In the absence of gravity, the hot gases produced by combustion no longer rise, and cold air does not sink to replace them. Instead, the reaction spreads out equally in all directions, forming a luminous, serene orb that seems to just hover in place. These spherical flames burn slowly, often with a dim blue color, as diffusion rather than convection delivers oxygen to the fuel. They burn at lower temperatures, but they consume their fuel far more efficiently because the chemical reactions spread uniformly through the available material. Astronauts aboard the International Space Station have observed such flames, describing them as eerily calm, like tiny floating stars. These perfect glowing globes reveal the true nature of fire when it is finally freed from the turbulence of earthly air currents. They show us that fire is not inherently chaotic, but serene. Quiet spheres of pure chemistry sustained by balance alone. And in certain conditions, fire can continue to burn in pure oxygen without any visible color at all. In an atmosphere of pure oxygen, combustion becomes so complete, so perfect, that it can lose its visible glow. Without unburned carbon particles or incomplete reactions to produce the familiar yellow or orange light, the process releases its energy primarily as heat and invisible ultraviolet radiation, which the human eye cannot see. The result is a nearly invisible flame capable of extraordinary temperatures. Such conditions are, of course, dangerous because the fire becomes incredibly hard to detect, even as it consumes material with astonishing speed. This kind of colorless combustion demonstrates a profound truth: that light is not an essential part of fire, but rather a beautiful byproduct of its imperfection. When chemistry proceeds flawlessly, the reaction becomes silent and unseen, a pure, invisible exchange of energy that reveals how close fire can come to being a ghost. Some metals are not usually thought of as fuels. Yet when they are finely divided or exposed to extreme heat, many can ignite with a brilliant, ferocious light. Magnesium, titanium, and aluminum all burn with dazzling white or blue flames, reaching temperatures that can surpass the melting point of basalt or granite. Once started, these reactions are nearly impossible to stop, because the metals react directly and fiercely with oxygen, forming stable oxides that release enormous amounts of energy. In welding and pyrotechnics, this intensity is harnessed deliberately. But in industrial accidents, it becomes terrifyingly destructive, melting through steel containers and concrete floors. These flames remind us that combustion is not limited to wood or oil, but is a universal process tied to the fundamental way that atoms exchange their electrons. When metals burn, they reveal the raw, primal power locked away deep inside matter itself. Lightning can fuse sand into glass in a single, silent flash. When a bolt of lightning strikes sandy ground, the heat can exceed 30,000 degrees Celsius, hotter than the surface of the sun. In that single violent heartbeat of sky and earth, the grains of silica melt and fuse together, forming hollow, branching tubes of natural glass called fulgurites. These fragile, beautiful structures preserve the exact path of the lightning as it traveled through the earth, sometimes stretching for meters deep below the surface. Each fulgurite is unique, a frozen record of an event that lasted less than a second. It is a piece of frozen lightning, a delicate skeleton of a storm. Scientists study them to understand the electrical and thermal effects of lightning, while collectors prize them for their delicate, alien beauty. The process that creates them mirrors the way that humans first learned to make glass, only on a far faster and more violent scale. We learned to mimic this with our furnaces and our careful hands. But nature does it with a single, thoughtless flash. In that one moment, nature performs its own act of artistry, turning ordinary, humble sand into a shimmering glass born of fire and storm. The core of that lightning strike reaches around 30,000 degrees Celsius, while the surface of the sun averages only about 6,000. It is a difficult thing to imagine. A temperature that exists for less than a second here on Earth. A brief piece of the sun brought down to our world. This unimaginable heat occurs as electrical energy rips through the atmosphere, forcing electrons to tear free from their atoms. The rapid, violent expansion of this superheated air creates the powerful shock wave we hear as thunder. It is the sound of the air being torn open. And then, rushing back to heal the space. In less than a second, molecules are broken, rearranged and scattered, leaving behind a narrow, glowing channel of plasma. The surrounding air then cools just as quickly, collapsing inward with a rush that deepens the thunderclap. The power of lightning demonstrates the immense energy stored in the sky's electric fields, an energy that is finally released in a single heartbeat. Though the strike lasts only for a fraction of a second, its incredible brightness and heat transform everything in its path. It is a stark reminder that even the air itself can burn under the right conditions. And yet, there are flames that can burn underwater when fueled by special chemicals. Some chemical reactions release enough of their own oxygen internally to sustain combustion, even when completely submerged. In the deep, cold, quiet of water, where fire should not exist. Compounds containing chlorine or fluorine can oxidize metals like magnesium and lithium, producing an intense, otherworldly light and heat while surrounded by water. These underwater flames appear almost supernatural, their soft light diffused through clouds of silver bubbles, a captured star burning in the dark of the sea. Naval engineers have studied them for use in emergency flares and underwater welding, where the oxygen from the reaction itself replaces what the water would otherwise smother. The key lies in the chemistry, not the air. As long as a fuel and an oxidizer are present together, fire can exist anywhere. These reactions illustrate that burning is not tied to the open atmosphere, but to the exchange of energy at the atomic level. Even beneath the surface of the sea, matter can still transform, releasing its stored energy as a gentle light that glows briefly against the dark, quiet water. Among the strangest substances known, white phosphorus is so reactive that it bursts into flame when simply exposed to air. It is so restless, so eager to change that the simple touch of air is enough. Its atoms are arranged in a strained, unstable structure that constantly seeks release by combining with oxygen. When that reaction begins, the material glows faintly in the dark before igniting into a bright yellow fire, producing dense white smoke. This faint glow before the fire is a kind of warning whisper, a chemoluminescence that hints at the energy waiting to be freed. Because it burns at low temperatures and continues until it is completely consumed, white phosphorus must be stored underwater or in an inert gas, shielded from the very air we breathe. The ease with which it catches fire demonstrates just how unstable certain chemical bonds can be, showing that sometimes the mere presence of air is enough to unleash the full power of combustion. On the slopes of Kawah Ijen in Java, volcanoes burn with a bright electric blue fire from sulfur gases. This is a fire not of wood or air, but of the earth itself. The flames are invisible by day, lost in the glare of the sun, but they blaze brilliantly at night as molten sulfur ignites when exposed to oxygen at temperatures above 360 degrees Celsius. The phenomenon looks otherworldly, surreal, as rivers of liquid blue fire flow silently alongside the molten rock. The color comes from the combustion of sulfur dioxide, a gas that burns hotter and with a different, more ethereal spectrum than ordinary flames. For generations, miners have worked near the crater, collecting the solid yellow sulfur for industry, walking among these glowing, silent streams of blue light. It is a place of haunting beauty and profound danger. The air is thick with the sharp scent of sulfur, a constant reminder of the planet's inner heat. The site demonstrates how volcanic energy can transform simple elements into the most vivid and mesmerizing displays of light. This blue fire is one of Earth's most haunting natural spectacles, a quiet and powerful proof that combustion can take unexpected and beautiful forms when born from the depths of the planet. From the fire within the earth, we turn our gaze upward to the fire that streaks across the sky. Meteor trails are miniature fires, tracing a silent, brilliant path through the upper atmosphere. When a meteoroid enters Earth's atmosphere, friction with the air molecules heats its surface to thousands of degrees. The intense, raw energy causes the rock or metal to vaporize, creating a glowing trail of plasma and molten particles. The streak of light we call a shooting star is actually this brief, beautiful combustion of material and air, lasting only for a second or two before fading back into the darkness. A silent farewell from a traveler who has journeyed for millions of years. Larger meteors can produce bright fireballs, leaving behind ionized trails that linger for a moment as glowing, ghostly lines in the night sky. The colors of these trails vary depending on their composition, with magnesium burning a brilliant white, sodium a familiar yellow, and nickel a soft, surprising green. It is the universe revealing its own chemistry in a fleeting signature of light. Though most meteors disintegrate entirely, a few survive the fiery descent to become meteorites on the ground. The burning trail they leave behind is a quiet reminder that even in the thin, cold upper atmosphere, fire can exist, born from the simple meeting of cosmic speed and earthly air. And sometimes fire finds its home on the surface of our world, moving with a power that feels ancient and unstoppable. Wildfires can move faster than a sprinting human. Driven by wind, slope, and dry vegetation, they can race across landscapes at astonishing speeds. Under extreme conditions, they may travel more than 20 kilometers an hour, fast enough to outrun people on foot. The immense heat from the flames preheats the nearby fuel, drying and igniting it before the fire even arrives. Embers carried by the wind like fiery seeds can start new spot fires kilometers ahead of the main front, creating a blaze that expands uncontrollably. The roar of a large wildfire is the sound of millions of individual combustions merging into one vast, unified reaction. It is a living thing with a living voice. Scientists study their movement through complex models and satellite data, hoping to predict their behavior and protect the communities that lie in their path. And yet, despite their immense danger, wildfires also serve ancient ecological roles, clearing out old growth and returning vital nutrients to the soil. Their power lies in the sheer scale of chemistry unleashed across the open air, a place where the wind becomes both an accomplice and the architect of destruction and renewal. Under the right, rare conditions, a wildfire or industrial blaze can form a rotating column of air and flame, known as a fire whirl or a fire tornado. It is one of nature's most stunning and powerful displays. As the intense heat rises rapidly from the ground, the surrounding air rushes in from all sides to fill the void, spinning faster and faster as it narrows into a vortex. The result is a fiery spiral that can reach hundreds of meters high, moving unpredictably and almost silently across the ground. It is a dance, a collaboration between the fire on the earth and the currents of the air above it. Inside this spinning column, temperatures can exceed 1,000 degrees Celsius, and the winds can surpass those of many hurricanes. Fire tornadoes are rare, but they are immensely powerful, able to lift heavy debris and spread burning embers far from their origin. Though they appear utterly chaotic, they obey the same fundamental laws of physics as ordinary whirlwinds, formed by convection and rotation, but amplified by the intense roaring heat of the fire. When nature's air currents and fire's raw energy align in just the right way, the atmosphere itself becomes a sculptor, shaping towering columns of flame that reach for the sky. And just as fire can reach up, it can also be forced down. In the presence of extreme wind, the familiar upright shape of a flame collapses, bending low to the ground as the air rushes past. It's as if the fire is humbled, forced to cling to the earth. The sheer speed of the wind feeds oxygen to the reaction much faster than convection can lift the hot gases upward, forcing the flame to tilt and run horizontally. This phenomenon can occur during intense wildfires or powerful storms, when hurricane-force winds whip through dry landscapes. The flame no longer looks like a gentle teardrop, but behaves like a living ribbon of light, crawling across the surface rather than rising above it. No longer reaching for the sky, but flowing like a river of fire. Even heavy rain sometimes cannot stop such fires if the heat remains intense enough to evaporate the moisture instantly upon contact. The sight of sideways fire captures the raw, primal interaction between motion and heat, showing how the elements can reshape one another under nature's most turbulent and powerful conditions. In the most intense wildfires, the firestorm can become so vast that it creates its own thunderclouds and lightning. The rising heat forms massive columns of air that behave like volcanic plumes, punching through the lower atmosphere. As these hot gases rise, they cool and condense moisture, forming towering anvil-shaped clouds known as pyrocumulonimbus. The fire becomes so powerful, it begins to create its own sky. Within these dense, churning clouds, particles of ash and ice collide, building up electric charge, just as they do in ordinary thunderstorms. Soon, lightning flashes above the blaze, sometimes igniting new fires miles and miles away. Winds swirl violently as air rushes toward the base of the storm to replace the rising column, feeding the inferno with even more oxygen. These incredible self-sustaining systems can generate winds stronger than hurricanes and temperatures that rival volcanoes. Entire weather patterns emerge from the fire's own energy, creating rain, hail, and lightning, all born from the combustion on the ground below. A firestorm is not merely an environmental event. It becomes an atmospheric engine, capable of shaping the very weather above it through the sheer, unstoppable power of heat rising into the sky. But these natural fires are not the hottest our world can produce. Under controlled conditions, flames can reach astonishing temperatures. Acetylene torches, for example, can burn hotter than 3,000 degrees Celsius when mixed with pure oxygen, hot enough to melt steel and vaporize glass. This is fire tamed, fire given a purpose. A pinpoint of starlight held in a human hand. Some chemical reactions, such as burning magnesium or thermite mixtures of aluminum and iron oxide, produce even more heat, glowing with a brilliant white light as they tear through metal. These extreme flames are used in welding, cutting, and industrial manufacturing, where precision and power demand temperatures higher than any volcano. At such heat, matter becomes a fluid of electrons and ions, radiating energy across the entire visible spectrum. The air around the flame shimmers violently as molecules are torn apart. While dangerous, these controlled fires reveal the outer limits of chemistry, where the boundary between a flame and pure plasma begins to blur into a single searing brilliance. And inside research facilities, scientists create bursts of plasma that reach temperatures in the millions of degrees. In fusion experiments, powerful magnetic fields confine hydrogen atoms so tightly that they fuse into helium, releasing energy as heat and light. For brief, fleeting moments, these artificial suns burn hotter than the core of any star. It is the quiet, humming echo of creation, held for a moment in a laboratory before returning to silence. In nature, extreme heat can transform rock into glass. When lava flows over sand or stone, or when lightning strikes the ground, the intense temperature melts the minerals and fuses them into smooth, shiny layers. This process, called vitrification, locks bubbles of gas and streaks of ash inside the glassy surface, creating a permanent record of the fire's passage. In nature, extreme heat can transform rock into glass. When lava flows over sand or stone, or when lightning strikes the ground, the intense temperature melts the minerals and fuses them into smooth, shiny layers. This process, called vitrification, locks bubbles of gas and streaks of ash inside the glassy surface, creating a permanent record of the fire's passage. In nature, extreme heat can transform rock into glass. When lava flows over sand or stone, or when lightning strikes the ground, the intense temperature melts the minerals and fuses them into smooth, shiny layers. This process, called vitrification, locks bubbles of gas and streaks of ash inside the glassy surface, creating a permanent record of the fire's passage. A very calm, soft, and soothing, slow-paced, with gentle intonation, designed for relaxation and meditation. Ancient hill forts in Scotland and Ireland show walls that have melted together, evidence of fires hot enough to fuse solid rock during battle or ritual. Imagine the heat required to turn a fortress of stone into a wall of glass. The fire that did this was more than a weapon. It was a force of geological change. The resulting black glass holds the memory of the fire's passage, frozen in solid form. Each piece tells a story of transformation, of solid matter briefly becoming liquid under heat so intense that it changes the landscape itself. The ability of fire to melt stone shows that even Earth's hardest, most enduring materials can yield to its touch. The stone does not forget. It is changed forever, carrying the fire's signature for thousands of years. And some fires cannot be tamed by ordinary means. When metals like magnesium, sodium, or aluminum ignite, they burn with a ferocious heat and react violently with water. Instead of cooling the fire, the water splits apart into hydrogen and oxygen, feeding the very flames it was meant to extinguish. The result is an explosive, violent reaction that can hurl molten droplets across wide areas. A betrayal by the one element we trust to bring relief. Water becomes fuel. It becomes a collaborator. Firefighters must use special dry powders, such as graphite or sodium chloride, to smother these blazes by cutting off their oxygen and absorbing their immense heat. In industrial settings, molten metal fires are among the most feared because they can melt through concrete floors and steel machinery. These reactions demonstrate that fire is not merely a surface phenomenon, but a deep, powerful chemical process that reshapes materials at the atomic level. In the wrong conditions, water becomes an accomplice, releasing new, explosive energy into the very flames it was meant to stop. The danger of fire can also hide in plain sight, in something as simple as dust. Finely powdered aluminum, when suspended in air, forms an invisible, flammable cloud of fuel just waiting for a spark. Each tiny particle has a vast surface area exposed to oxygen, allowing combustion to happen almost instantly once ignited. The reaction releases immense energy, producing shock waves and intense, blinding heat. This phenomenon is known as a dust explosion, and it can occur not only with metals, but also with organic materials like flour or coal. A quiet factory, a silent mill, filled with an invisible potential for fire. The danger lies in the combination of chemistry and geometry, where countless tiny particles turn the air itself into fuel. In that one sudden moment, the boundary between a solid substance and the raging flame disappears completely. The same invisible threat exists with gasoline. Liquid gasoline itself does not burn until it evaporates, releasing a cloud of flammable vapor. It is the breath of the fuel, not the fuel itself, that holds the danger. When that vapor mixes with air in just the right proportion, even a tiny, invisible spark can cause ignition. Static electricity from clothing, from a sliding surface, or from the air itself can be enough to trigger a devastating flash. The energy required to start the reaction is minuscule, yet the result can be catastrophic. The flame travels almost instantly through the vapor cloud, returning to the liquid surface and setting it ablaze. The lesson from this quiet chemistry is that the greatest danger often hides in the invisible. Fire can begin not from large, roaring flames, but from the smallest, quietest spark, where energy and vapor meet for a single, silent instant. Even snow, a substance we see as the absolute opposite of fire, can burn if mixed with the right chemicals. Under the right conditions, fire can exist even within the most frozen landscapes. Certain chemicals, such as sodium or potassium, react violently with water by releasing flammable hydrogen gas and immense heat. When these elements come into contact with snow or ice, the reaction can generate enough heat to ignite the hydrogen, creating flickering flames that seem to rise directly from the frozen surface. It is a paradox made real, a perfect defiance of instinct. Yet it follows the simple, elegant laws of chemistry. The same reactions are used in controlled experiments to teach how exothermic processes work, how energy can be released from a state of cold. These burning snows reveal that fire does not depend on the surrounding temperature alone, but on the energy stored deep within chemical bonds. When those bonds break and recombine, heat and light appear, regardless of the environment. Even in the coldest, most silent place, the laws of energy remain unchanged, allowing a flame to bloom where ice should rule. And just as fire can appear in unexpected places, it can also appear in unexpected colors. Flames can appear green when copper is part of the fuel. When copper or its salts enter a flame, their electrons absorb the energy and jump to higher levels. As they fall back, they release that energy as light in the green part of the spectrum. This creates a vivid emerald glow that stands out against the warmer, more familiar hues of most fires. A very calm, soft, and soothing voice, slow-paced, with gentle intonation. The effect is most commonly seen in fireworks, where copper chloride or copper acetate is used to produce brilliant green bursts that paint the night sky. But in laboratories, the same colors appear when copper compounds are heated for analysis. The color depends on the specific compound and the temperature of the flame. A subtle and beautiful language. Even trace amounts of copper can tint a fire, revealing its hidden chemical fingerprint. It is a brief glimpse into the quantum world. The phenomenon demonstrates the intimate, beautiful connection between light and matter, where the invisible atomic structure determines the visible color. Each green flame is a momentary window into the quantum behavior of elements, showing how invisible atomic energy becomes visible as pure beauty. Some types of alcohol, such as methanol or ethanol, can burn so cleanly that the flame produces very little soot and almost no visible light. In bright sunlight, these fires are nearly impossible to see, though they still release an intense shimmering heat. A fire with no body, only its warmth, a ghost of a flame. The reaction between the alcohol vapor and oxygen creates mostly carbon dioxide and water, leaving no glowing carbon particles behind to color the flame. This property makes alcohol fires both useful and incredibly dangerous, especially in laboratories and in high-performance racing fuels, where an accidental ignition may go completely unnoticed until it is too late. This invisible flame can be detected only by the heat it radiates, or by its faint, ghostly blue glow in dim light. Firefighters and chemists use special thermal cameras or ultraviolet sensors to identify these hidden fires. The very purity of the combustion makes them ghost-like, a quiet and powerful reminder that not all flames announce their presence with a brilliant glow. Sometimes, the most complete fires are the hardest to see. They are a whisper of pure energy, a silent, invisible transformation happening in the open air. The first wildfires began long before the first trees evolved. In the ancient, silent past of our world, lightning strikes would set fire to primitive plants and the dry, sprawling mats of algae on land. Imagine a world without forests, a world of low, green vegetation, and fire moving across it like a shallow, flowing sea of light. These early wildfires consumed the small, low plants and released gases into the atmosphere, influencing the delicate balance of oxygen and carbon dioxide. Fossilized charcoal from nearly 500 million years ago preserves the quiet, ashen evidence of those ancient burns. The arrival of great forests only intensified the cycle, as wood provided a denser, more powerful fuel, and oxygen levels rose high enough to sustain massive, continent-spanning fires. Wildfire thus predates the very forests we know today, and even the complex ecosystems that depend on them. It has always been a part of Earth's deepest rhythm, shaping evolution by selecting for species that could resist or recover from the passing of the flame. In those early, quiet ages of the world, fire began its eternal role as both destroyer and creator, helping to sculpt the very landscapes where all of life would later flourish. For millions of years, lightning was Earth's earliest and only natural ignition source. Before humanity learned to strike sparks from stone, lightning was the one force capable of setting the world aflame. A marriage of the sky and the earth, a moment of pure, raw energy. Each bolt carried millions of volts, striking the early trees, the vast grasslands, and the beds of dry peat. The resulting fires transformed entire landscapes, releasing nutrients back into the soil and clearing space for new growth to begin. A very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. The animals of that time fled or adapted, and the plants evolved traits that allowed them to survive, or even depend on periodic burning. The ancient atmosphere was rich in reactive gases, making ignition frequent and widespread. Some scientists believe that these natural, planet-spanning fires helped to shape the planet's chemistry, producing complex compounds that later contributed to the development of life itself. Every time lightning flashes in our sky today, it recreates the same ancient process that first connected the heavens and the earth through flame. It remains a living, breathing reminder of nature's awesome power to spark transformation, bridging the fierce energy of the sky with the quiet, waiting matter of the world below. And into this world of natural fire, humanity was born. Early humans learned to keep embers alive long before they ever learned to spark new ones. They discovered that fire could be preserved, it could be carried, even when they did not know how to create it from nothing. By covering glowing embers with ash or carrying smoldering sticks from place to place, they kept heat alive for days or even weeks. These precious traveling fires provided warmth, protection, and the means to cook food. Archaeological evidence shows ancient hearths where our ancestors maintained coals over long periods, indicating that this skill of firekeeping was vital for survival. A sacred duty, a shared responsibility. Only much, much later did humans finally learn to strike sparks from stone or create friction fires with tools. The ability to keep embers alive bridged the vast gap between discovery and mastery, allowing early societies to migrate and thrive in new, colder environments. Each preserved ember was a small, captured seed of civilization, a living piece of the wild world's energy, carefully and hopefully into the great unknown. Charred bones in ancient caves show that early people cooked with fire almost 2 million years ago. It is a staggering thought. A fire burning with a purpose 2 million years in our past. Archaeological sites in Africa reveal blackened bones and layers of ash that date back to this incredibly distant era. Direct evidence that early humans not only used fire, but had begun to understand its incredible potential. Cooking softened tough meat, made fibrous plants easier to digest, and unlocked vital nutrients that raw food simply could not provide. This profound dietary shift supported the growth of larger, more complex brains and changed the course of human evolution forever. A simple act, cooking food over a flame, and it unlocked our future. The traces left in those ancient caves show deliberate, repeated fire use in the same spots rather than just accidental burning. These hearths, these simple circles of stone and ash, mark some of the very first steps toward technology and culture. Fire ceased to be a terrifying, wild threat and became a tool, a companion, a partner that shaped human destiny. The gentle glow of those first prehistoric flames still burns in every meal we eat, every lamp we light, and every home we build, carrying forward the light first kindled in the deep, silent shadows of those ancient caves. With this newfound light, human activity was extended far beyond the daylight hours. For most of prehistory, nightfall meant an end. It meant darkness, danger, and a forced rest. But fire changed that forever. With light, people could gather together, cook their meals, craft their tools, and tell stories long after the sun had set. The flickering glow of torches and campfires created the first true social spaces, safe, warm circles of light where communities formed and culture began to grow. The shadows moved like living, breathing shapes across the walls of caves and shelters, inspiring imagination, ritual, and art. The steady warmth of the flame kept the great predators of the night at bay and gave a profound sense of safety in a vast, dangerous wilderness. Over countless generations, firelight became a symbol of knowledge and spirit, a beacon of awareness in a world of deep, unending night. It transformed time itself by extending the day, allowing for thought, for creativity, and for connection to continue beyond nature's simple rhythm. Every spark of human progress, every great idea, every quiet moment of invention began in those sacred hours when darkness met flame and human minds first learned to truly think by its gentle, hypnotic glow. In the ancient wilderness, the circle of light from a campfire marked the very edge of safety. It was a fragile, flickering border between the human world and the wild world. The rich scent of smoke and the constant, gentle crackle of the flame kept animals wary, while the heat discouraged insects and the biting cold. Early humans gathered close to these small, precious barriers of light, resting with the deep knowledge that few creatures would dare to cross into the glow. The campfire became a fortress of flickering motion, a living, breathing guardian that never slept. And within its protected radius, humanity began to dream. It was in these quiet moments, safe from the dangers of the night, that we began to invent tools, stories, and songs. Fire did not just protect human life. It gave us the sacred space for reflection and for cooperation, the very things that would shape the entire course of civilization. And it was there, in the quiet of the night, that we may have first found our voice. For countless generations, humans gathered at night to share warmth and to share tales. Anthropologists believe that the campfire's circle may have been the first classroom, the first theater, where elders passed down knowledge through the spoken story. In that gentle, flickering glow, early language could evolve from simple sound into deep meaning, allowing for complex communication to finally take shape. The interplay of voice, shadow, and emotion turned the firelight into a stage for the imagination. Every word, every myth, and every lesson told by the light of the flame was carried forward through time, shaping culture and memory, and shaping us. The discovery of spark-making stones was one of the great quiet turning points in human history. Imagine that first moment, a moment of pure chance and profound discovery. A sharp click of stone on stone, and in the darkness, a tiny glowing star was born for just an instant. When flint or chert was struck against iron-rich minerals like pyrite, tiny fragments of the stone flew off, glowing with intense heat. Those precious, fleeting sparks could ignite dry grass or tinder, creating fire on demand. Mastering this simple, elegant technique freed people from their dependence on natural flames and preserved embers, allowing them to make fire anywhere, anytime. It was the moment we stopped just finding fire and started making it. Archaeological evidence of flint tools shows that ancient humans carried specialized stones for this very purpose. The rhythm of striking and catching a spark became a vital ritual of survival. And each success marked the triumph of human knowledge over mere chance. With every new flame, humanity gained a deeper control over energy, transforming a wild, dangerous force into a dependable utility. The spark between those two stones was more than just fire. It was the first, clear expression of human ingenuity. The moment when our intelligence met the deep, hidden physics of the earth. And the mastery of fire reshaped human evolution by allowing cooked food and constant warmth. Cooking changed everything. By breaking down tough proteins and complex starches, heat made food easier to chew and to digest, freeing up metabolic energy that was once spent on raw sustenance. This surplus of energy fueled the development of our brains and our physical endurance. The warmth of a controlled flame allowed our ancestors to migrate into colder climates, expanding the human presence across the entire planet. Fire also sterilized water and food, reducing disease and improving health. Over generations, it shaped our anatomy, our behavior, and our culture. Social life formed naturally around the shared hearth, where cooperation and community began to replace mere competition. The mastery of the flame thus marks the delicate boundary between raw instinct and the dawn of civilization. In its gentle light, humans became the creators of their own environment, no longer bound by the simple, ancient rhythms of the sun and the seasons. The story of our evolution is incomplete without fire, the constant companion that carried humanity from the wild into the warmth of its own making. In the earliest myths, fire was seen as a living being, breathing and moving with its own mysterious will. Some early cultures believed that every single flame held a spirit. It was not just a tool. It was a guest in the home, a presence. They believed that each flame contained a consciousness, a divine essence that connected the human world to the sacred one. Ritual fires were tended with immense care and respect, fed with offerings of food, oil, or fragrant incense. Many traditions saw the flame as a messenger, carrying prayers upward to the heavens in its rising smoke. In temples and on hearths, the fire was both a utility and a presence, symbolizing purity, transformation, and eternal renewal. The way it consumed, yet created, inspired a deep and lasting awe and reverence. Even today, the simple act of lighting a candle preserves that ancient, quiet belief in the flame as a living spirit. Across all cultures and all of time, the fire's glow continues to represent life itself, a soft, flickering reminder that energy, warmth, and soul are all intertwined in the silent, hypnotic dance of light. Across ancient civilizations, the rhythm of time was kept not only by the stars and the sun, but by fire. Great pyres and torches were lit at solstices, at harvests, and at equinoxes to honor the great, silent turning of the heavens. These ceremonies carried a profound and sacred meaning, connecting the small, fragile lives on earth with the vast, eternal cycles above. In many cultures, the flame represented renewal, its brilliant light mirroring the rebirth of the sun or the return of fertility to the land. It was a way to participate, to feel a part of the great cosmic story. Priests and villagers would gather in circles of heat and shadow, watching the sparks rise like a river of prayers into the deep night sky. Fire became the medium between heaven and earth, a visible, living heartbeat of the cosmos. Its warm glow measured both time and transformation, reminding humanity that our own existence follows the same quiet path as a burning log. Ignition, a brief brilliance, and then a slow, gentle fading into embers. Through these ritual fires, the universe was celebrated as something living, cyclical, and divine. And from this deep reverence came a new kind of understanding. Long before coal or oil were ever known, ancient people discovered that burning wood without air produced a lighter, purer, and more powerful fuel. By covering wood with clay or soil and allowing it to smolder slowly, they created charcoal,
a black, porous material that burned hotter, cleaner, and much longer than its source. This breakthrough, this quiet innovation, revolutionized the use of fire. It was humanity's first act of true fuel engineering. Charcoal allowed for higher temperatures that could finally melt metals and fire ceramics, unlocking new worlds of technology. It powered the first forges, the first kilns, and eventually entire economies. Archaeological sites show charcoal pits dating back tens of thousands of years. Quiet, humble evidence of a deliberate and masterful control over chemistry. Unlike raw wood, charcoal could be stored indefinitely and transported with ease. It marked humanity's first great step toward manipulating matter on purpose, transforming a simple, natural flame into a precisely engineered tool. It was the quiet bridge between the natural world and the artificial one, the place where human intention met the hidden, elegant science of heat and transformation. The control of fire enabled the first permanent settlements in the cold regions of the world. Before the mastery of heat, human migration was limited by the seasons, confined to the warmer climates. Fire changed that map entirely. A very calm, soft, and soothing from predators. With the ability to create and sustain warmth, people could finally survive the harsh winters, store food for longer periods, and build permanent shelters. A house became a home. In previously uninhabitable places, the hearth became the true center of these early homes, and the surrounding villages grew around these dependable, life-giving sources of heat. The stability of fire meant that families could remain in one location through the changing seasons, cultivating the land and raising animals. Archaeologists find ancient hearthstones in the remains of dwellings all across Europe and Asia. Quiet, powerful proof that the flame was the very foundation of settlement. Beyond mere survival, the fire brought comfort, light, and a deep sense of safety from predators. It allowed humans to turn the cold, dark wilderness into a livable, breathable space. The steady, gentle glow inside those first huts and caves marked the true beginning of civilization's expansion into the wider, colder world. The story of pottery likely began with a simple, beautiful accident. Clay left too close to a hearth would have cracked, darkened, and then hardened into a new and surprisingly durable material. People soon realized that heat could transform this fragile, common earth into vessels that could hold water, food, and grain without leaking. It must have felt like magic to take mud and turn it into stone. This discovery changed daily life forever. Pottery made storage possible and cooking more efficient, allowing communities to settle and to grow. Over time, firing techniques became more sophisticated, evolving from open flames to enclosed kilns, capable of reaching much higher, more consistent temperatures. And decoration soon followed utility, with painted and carved designs turning simple containers into works of art.
Every single ceramic shard unearthed by archaeologists today carries the fingerprints of that first, quiet revelation. The understanding that fire could not only destroy, but also create. The first metal may have been discovered by complete accident. Imagine a fire burning hotter than usual, banked by certain strange, heavy rocks. When the ancient flames died down and the ashes cooled, someone noticed something new among the embers. Shiny, heavy beads glinting in the morning light. Molten droplets of copper or lead, having seeped out from the stone, had appeared among the ashes. Drawn to their unexpected brightness, early humans began experimenting with these strange, beautiful materials, learning that intense heat could extract them from the earth. This quiet, simple curiosity gave birth to the art of smelting and the entire field of metallurgy. By building hotter fires with charcoal and bellows made of animal skin, people transformed raw ore into tools, into ornaments, and into weapons. Metal reshaped human society, replacing the fragility of stone with strength and flexibility. The spark of wonder that led someone to pick up those first glimmers of metal from the ash opened the path to our entire modern technological world. Every single bead found in the quiet coals of an ancient hearth was a tiny, silent revolution. It was proof that fire could reach deep into the earth and bring out its hidden, shining treasures. And according to legend, ancient glass was discovered in a similar way, when merchants were cooking over a sandy beach, using blocks of mineral soda to support their pots. The intense heat of their cooking fire melted the sand and the soda together into a translucent, flowing sheet, revealing a new substance unlike any other. Whether this story is myth or truth, early glass appeared wherever fire met silica and alkali in just the right combination. Natural glass also formed from lightning strikes and volcanic flows, inspiring our ancestors to imitate it. Once humans learned to recreate the process deliberately, glass became one of civilization's most defining materials. It was a kind of magic, a solid that you could see through. It allowed light to pass while protecting from the elements, turning fire's destructive heat into an act of pure creation. Ancient glassmakers were revered as alchemists, as masters who could turn common earth into perfect clarity. Every window, every lens, and every vessel today owes its existence to that first wondrous moment when someone looked into the pooling, glowing sand and saw the miracle of melted light. Before oil lamps or candles, humans lit their nights with simple torches. The first ones were likely just sticks of wood soaked in the resin-rich sap from pine or birch trees. These simple tools burned with a bright, steady light, allowing the flame to be carried from one place to another. It was fire made mobile, a piece of the hearth, a portable sun. These handheld fires illuminated deep caves, guided nighttime hunts, and marked safe paths through dark forests.
the sticky resin acted as both a fuel and a glue, holding the ember to the wood and helping it resist the wind or the rain. Some of the oldest cave paintings show faint soot marks along the high walls and ceilings, the quiet, lasting evidence of torchlight guiding the artists as they worked deep underground. Over time, torches became powerful symbols of ceremony and knowledge, carried in rituals and processions. Their steady, dependable flame represented the continuity of light in a world of darkness.
A very calm, soft, and soothing voice. Each one was both a simple tool and a profound symbol, a portable star that allowed humanity to explore, to create, and to connect beneath the vast, dark canopy of the prehistoric world. And from the torch came the lamp. Long before candles, people used shallow bowls carved from stone, filled with melted animal fat, to create a contained, steady light. A strip of plant fiber or a piece of soft moss served as a wick, drawing the liquid fuel upward where it would burn with a dim but incredibly enduring flame. These primitive lamps illuminated the earliest homes, caves, and sacred shrines. The smoke from the burning fat would cling to the walls, leaving behind a black residue that still stains ancient dwellings today, a silent fingerprint of life and warmth. Though simple, these devices extended the day and made indoor life truly possible. Archaeological finds show beautifully carved lamps, shaped like animals or adorned with sacred symbols, revealing that they carried spiritual significance as well as practical use. The gentle warmth and the soft, hypnotic flicker of these tiny flames offered a quiet companionship against the long, deep night. Each small lamp was a contained fragment of the sun, tamed to rest upon a hearthstone, whispering quietly while the world outside lay in shadow. In parts of ancient Persia and India, sacred fires were tended continuously for centuries, burning in temples built for that single purpose. These were fire temples, homes for flames that were never allowed to go out. These temples were built around fires that symbolized eternal truth, purity, and a divine cosmic order. Priests would guard them day and night, feeding the fire with precise, ritual offerings of wood or oil, always maintaining its perfect, steady balance. A very calm, soft, and soothing voice, slow-paced with gentle intonation, designed for relaxation and meditation. The constant, unwavering burning represented the unbroken connection between the material world and the spiritual one. To let the fire die was to break a cosmic link, to let a promise to the gods go unkept. Some of these eternal flames still exist today, preserved through generations of unwavering devotion. Imagine the history held in that light. A single flame tended for 1,000 years, passed from one generation to the next, a living soul for an entire culture. It is among the earliest and most profound expressions of humanity's deep reverence for light as a living force. Within those ancient temples, the steady glow was more than just warmth or brightness. It was the very embodiment of continuity, a flame that outlasted empires and carried the memory of belief itself. This reverence is woven into our oldest stories. Mythologies across the entire world describe gods or heroes who stole fire for humankind. The gift of the flame appears in countless ancient stories, from Greece to Polynesia to the Americas. In the Greek legend, the Titan Prometheus defied the gods to bring fire down to humanity. And for his act of compassion, he suffered an eternal punishment. In Polynesian tales, the hero Maui stole it from the dark underworld, while in some Native American myths, the animals themselves conspired to capture it for the first people. These stories, though born in different corners of the world, reveal a universal recognition of fire as something both divine and dangerous. To possess it was to share in the power of creation itself. Fire symbolized both knowledge and rebellion, the spark that finally separated humans from the rest of nature. The theft of the flame became the mythic, pivotal moment when our intelligence and our spirit fused together, marking the true dawn of civilization. And yet, long before our myths, fire was an ancient and essential part of the planet's life cycle. Long before humans ever existed, lightning would ignite the vast, silent forests and plains, setting off great, sweeping cycles of destruction and renewal. These natural fires shaped entire ecosystems by clearing away old and dying vegetation, releasing nutrients back into the soil, and making space for new growth to begin. To the modern mind, a wildfire seems purely destructive, a catastrophe. But in the deep, slow time of nature, it is simply a part of the balance. Forests and grasslands are living systems, and they need this kind of disturbance to truly thrive. Fire resets the clock of the landscape, ensuring diversity and regeneration. Many plants not only adapted to this cycle, they evolved to depend on it. In fire-prone regions, evolution found a remarkable strategy for survival. Certain plants produce cones or seed pods that remain tightly sealed, sometimes for decades, until they are exposed to the intense heat of a fire. When a wildfire sweeps through, the heat melts a tough resins or cracks the hard outer shells, releasing the seeds into a bed of nutrient-rich ash. This incredible adaptation ensures that new growth begins at the precise moment when competition from other plants is lowest and the soil is freshly fertilized. High in the mountain forests and across the dry plains, some pine species guard their seeds inside cones sealed shut with pitch.
These cones can hang on the branches for years, patiently waiting for a fire to pass through.
When the flames arrive, the heat softens the resin, allowing the scales of the cone to spread apart and release the seeds within. The ground below, now cleared of all underbrush and coated in a soft layer of mineral-rich ash, becomes the perfect nursery for a new generation of trees. In this way, fire becomes a partner in life rather than an enemy. Across the vast savannas of Africa, the great prairies of North America, and the wind-swept steppes of Eurasia, natural fire acts as a great cleansing force. It is not an intruder here, but a gardener. Flames sweep across the land, removing the dry, dead vegetation of past seasons, recycling vital nutrients, and preventing trees from overtaking the wide open plains. After a burn, the grasses regrow with astonishing speed, nourished by the fresh ash and the open, unfiltered sunlight. It is a quiet miracle of renewal. The animals return soon after, following the promise of new life, feeding on the tender green shoots that emerge from the blackened earth. For millennia, many indigenous cultures recognized this deep, ancient rhythm and practiced their own controlled burning to maintain the balance and abundance of the land. Without fire, these grasslands would slowly but surely transform into dense forests, losing the unique and beautiful diversity of life that depends on open space. These ecosystems evolved alongside the flame, and their very fertility depends on its periodic return. The soft green waves that follow a burn are the Earth's quiet, graceful expression of renewal. And this renewal is sparked most often by the sky itself. At any given moment, somewhere on Earth, lightning is striking. It happens constantly, a silent, flickering pulse of energy connecting the clouds and the ground. Every day, these strikes start thousands of natural fires all around the world, in forests, deserts, and grasslands. Most of them extinguish quickly, tamed by rain or humidity, but some grow into vast, sweeping blazes that shape entire ecosystems. Each one of these events links the atmosphere to the ground in a direct and powerful exchange of energy. A single strike carries immense power, heating the air to tens of thousands of degrees in a fraction of a second. And when that incredible heat meets dry vegetation, the spark becomes a flame. This lightning-driven fire is one of the oldest and most fundamental natural processes on our planet, responsible for maintaining the balance of life long before humans ever appeared. What begins as a silent, brilliant flash in the clouds becomes a force that renews the earth, a quiet and constant reminder that even destruction
has a profound purpose in nature's grand silent design. Fire creates the very nutrients that feed the next generation of growth. When vegetation burns, the complex organic matter that once held nutrients in its structure breaks apart, releasing essential minerals like potassium, calcium, and phosphorus directly into the soil. These simple, vital elements then dissolve into the rain and seep down to the roots of new plants. The result is a sudden, vibrant burst of fertility in the seasons following a fire, often visible as brilliant carpets of green and wildflowers spreading across a once blackened land. In this way, fire transforms locked-up energy and matter into forms that are once again accessible to life. What looks like utter devastation is simply one part of a much larger, more beautiful pattern of renewal, a kind of planetary metabolism, where the flame plays a vital and necessary role. Every new sprout that rises from the charred soil carries within it the living memory of the fire that fed it. After a fire, the fine, soft gray powder left behind is more than just a residue. It is chemistry waiting to restore balance. Ash contains alkaline minerals that gently counteract the natural acidity in the soil, improving the conditions for many species of plants. It is a quiet healing, a slow rebalancing of the earth. When the rain comes, it mixes with this mineral dust, creating a mild, nourishing solution that seeps deep into the ground, unlocking nutrients and encouraging microbial activity. The forest floor, blackened and still, becomes a silent laboratory of life. From this quiet, patient chemistry, new vegetation emerges, a soft green proof that even in the immediate aftermath of a great fire, the earth is already beginning to heal itself. And the animals of the world, they learned to watch the fire. They learned its rhythms and its promises. In parts of Australia and Africa, a strange and beautiful thing happens. Certain birds of prey, such as black kites and brown falcons, have been observed picking up smoldering branches from the edges of wildfires and carrying them to unburned areas. They drop these embers into the dry grass, deliberately spreading the flames. This remarkable act drives insects, lizards, and small mammals out into the open, where the birds can then easily catch them. Indigenous peoples have known of this behavior for countless centuries, calling these species the firehawks. They are not merely observers, they are participants. They are fire wielders. Scientists who finally documented this behavior confirmed one of the few known cases of animals manipulating fire as a tool. The sight of a bird carrying a burning stick blurs the line between pure instinct and a deep ancestral intelligence, revealing a cunning and profound adaptation to an ancient force. And other creatures are drawn to the fire, not for the hunt, but for the renewal that it brings. Certain species of fire beetles possess extraordinary, almost magical sensory organs that allow them to detect the infrared radiation produced by forest fires from many, many kilometers away.
They feel the heat as a distant, gentle promise on the wind, and they fly toward it, not away from it. This is because the freshly burned wood is the perfect, safe place for them to lay their eggs. The larvae will feed on the weakened trees and the charred bark, thriving in a world where other creatures cannot yet survive. These beetles are equipped with tiny infrared receptors, so incredibly sensitive that they can sense temperature changes smaller than a single degree, far surpassing many of our own human-made detectors. In a way, they have evolved to follow the fire as others might follow the scent of water or the light of the moon. Their strange, deep attraction to the heat shows how profoundly fire is woven into the very fabric of life, guiding even the smallest of creatures through the great, silent cycles of destruction and renewal. While the slow forces of wind and water gradually shape the surface of the earth over millennia, fire works in moments. A single sweeping blaze can alter entire ecosystems in a matter of hours, stripping away vegetation, exposing the soil, and changing the chemistry of the air and the ground alike. Hillsides blacken, dense forests open up to the sky, and new patterns of life emerge within days. The rapid transformation caused by fire rivals the great geological forces in its sheer impact. Yet it operates on a human timescale. We can watch it happen. Afterward, the landscape does not simply return to what it was before. It becomes something entirely new, shaped by both the memory of its loss and the promise of its potential. The incredible speed of this process reveals how pure energy can remake the planet, reminding us that change need not be slow to be profound. Fire is Earth's sudden sculptor, carving renewal out of what first appears to be devastation. And after a wildfire passes, the blackened remains of the trees might look lifeless and desolate, yet they serve a vital, quiet purpose. The dark carbon residue left behind forms a thin protective layer that absorbs the rainfall and holds it in the soil. Beneath this charred black blanket, the roots, the seeds, and the microorganisms find a quiet refuge, insulated from the harsh, direct sunlight above. The burned wood acts like a gentle sponge, slowing evaporation and preserving the precious moisture through the early, fragile stages of regrowth. This paradox of destruction creating the very conditions for recovery shows how deeply nature understands balance. A blackened forest floor may appear silent and dead, but deep within it lies the hidden, steady pulse of renewal, waiting patiently for the rain and the sunlight to return. Fire shapes the great migration paths of animals across entire continents. For countless species, the presence of fire, or the memory of its passing, determines when and where they move. It is a silent signal, a promise written on the wind. The great grazing animals follow the fresh, tender green shoots that spring up in the wake of a burn, finding deep nourishment in the renewed growth. They read the land with an ancient wisdom and know that where the fire has been, life will soon return in great abundance. Birds of prey and scavengers gather at the edges of the flames, hunting the insects and small animals that are fleeing the heat. Even the largest migrations in Africa and Australia often follow the seasonal burn patterns, moving in perfect ancient harmony with the cycles of fire and regrowth. Over vast stretches of time, these patterns have carved invisible, instinctual trails across the land, guiding the great herds, the flocks of birds, and the watchful predators alike. Fire becomes a map, a living, changing map written in light and ash, directing the great flowing river of life towards sustenance and renewal. And the fire gives back to the sky in the form of smoke. When a great fire sends its plumes of smoke rising into the air, it releases countless tiny particles that drift high into the atmosphere. These microscopic bits of ash and carbon become seeds, floating seeds for clouds. They give the water vapor in the air something to cling to, a place to gather. In time, great clouds form around them, thickening into storm systems that can eventually release the gift of rain. It is a perfect circle, a beautiful paradox. Some regions even experience increased rainfall downwind of large fires, as the smoke changes the way the sunlight and heat interact with the atmosphere. What rises from the earth as a sign of destruction can return as a gift of renewal, as cool, gentle rain falls back upon the scorched earth it was born from. But the balance is delicate, always so delicate. If there is too much smoke, it can block the sun's light, cooling the air and preventing the clouds from ever forming at all. And deep beneath the ashes of a forest fire, a hidden life awakens. Certain species of fungi, their spores having lain dormant in the soil for decades, even centuries, sleeping, just waiting, are awakened by the intense heat and the unique chemical changes that only a fire can bring. They are the patient ones, the keepers of renewal. Once the ground has cooled, they emerge with a surprising speed, sending up their dark, beautiful fruiting bodies that feed on the charred remains of plants and wood. These fungi are the great recyclers of the forest, playing a crucial ecological role by breaking down the tough, carbonized material and returning its precious nutrients to the soil. In a place that looks utterly ruined to our eyes, this new life is already rewriting the soil's chemistry, turning the memory of destruction into the possibility of a fertile future.
Before human settlement and agriculture reshaped the land, the vast prairies of North America burned regularly in immense natural fires that could travel for weeks on end. A sea of grass met by a sea of flame. But these fires rarely destroyed the ecosystem. Instead, they renewed it. The grasses had evolved to grow back quickly, their deep roots surviving safely below the reach of the heat. The same is true of the savannas. In these tropical regions, the combination of grass, trees, and seasonal rain creates ecosystems that depend on frequent fire. Savannas are not devastated by burning. They are renewed by it. Fire acts as both a boundary and a sculptor, keeping open what would otherwise close. It prevents the dense forest from forming, preserving the wide open plains that support elephants, lions, and the great migrating herds. In every flicker across that distant horizon lies the quiet, eternal collaboration between the earth, the rain, and the flame. An eternal partnership that ensures the land can continue to breathe. And so we come to the final, quiet truth. Every flame on earth is a faint, gentle echo of the stars that forged its atoms. The very atoms in your body, the carbon in your breath, the calcium in your bones, the iron in your blood, they were all born in the same place, in the heart of a star long ago. A star that lived and burned and then died in a final, brilliant act of giving. When those ancient stars exploded, they scattered their precious elements through the silent darkness of space, seeding the great clouds of gas and dust that would one day become our Earth, and one day become us. So when you gaze at a fire, you are looking at family. You are seeing a distant reflection of your own cosmic origin. Each tiny spark that we light continues that original magnificent fusion. The same quiet transformation of matter into energy that began in the heart of the cosmos. A simple candle flame burning softly in your room connects you directly to the life cycles of suns that have long since vanished. Its gentle light carries the memory of explosions beyond our imagination, condensed into a warmth that we can hold in our hands. Fire is not merely a human discovery. It is a cosmic inheritance, a gift from the stars themselves. Every single flicker in the dark is the universe remembering itself, burning quietly in miniature, whispering the silent, beautiful story of its own beginning. As the light of the last flame fades, the mind begins to soften. You have wandered through the secret, silent chemistry of fire, through the sparks that whisper the language of the stars, and the embers that carry the memory of creation itself. Each flicker has been a gentle reminder that what burns is never truly lost. It only changes its form, finding new and beautiful ways to glow. Fire is a teacher of transformation. It shows us how energy moves, how stillness so often hides a deep and profound motion, and how every single atom carries a story far older than time.
The very same forces that warm a candle's edge are the ones that ignite the hearts of suns, shaping everything we see and everything we are. To watch a fire is to witness the universe remembering itself, transforming endlessly and gracefully from one shape of light to another. And now that warmth begins to settle deep within you. The body grows heavy, a comfortable, welcome weight. Your breath deepens, slowing to an ember's quiet, steady rhythm. The thoughts of the day begin to slow and soften and fade. The room around you dissolves into a gentle softness of shadow, while the quiet echo of the fire continues somewhere far, far away in the deep hush between worlds. There is nothing left to do now but to let go. Let yourself drift with it. Feel the profound calm that follows every last spark. The deep, absolute stillness that now holds the memory of the flame. Somewhere, far beyond your sight, the stars are still burning. Their ancient, silent light is flowing through the dark, traveling for millions of years just to reach us. It greets you even now, gently, like a final, tired spark finding its way home to rest. Your eyes are already closing, so let the glow fade completely. Rest now in the deep, soft warmth of the quiet that remains. The fire is still out there in the hearts of the stars, watching over everything, and it will be waiting for you when you wake. There is only stillness now, only peace. Good night.